Okay, cool. All right, so I guess we'll get started. You guys can all see my screen well and hear me. All right, cool. Let me just get everything set up on my screen. All right, cool. So welcome everybody to our 4th BDAA workshop. So exciting. We got one more after this. But for those of y'all who don't know me, my name's Alec. I'm the co-VP of the tech team here at BITS. And before we start this, I don't know how many of you guys have installed our studio. Can I get like a nice thumbs up, thumbs down for installations? Okay, Kenan. Okay, Yusra. Wow. Okay. We still got some thumbs down. So I'm gonna put in some links here to install it. Let me just see this. You can just go to this website and do it. That's the website. I made a video tutorial on how to do it. So if you get confused, do that. And I also made a like a written description on how to get through that. So there's all of that. If you want to go through that. And if not, and you don't want to install it, you can use this website to kind of follow along. But it's honestly not 100% the best, but it works. Like you can do all the commands. There's just some weird thing. It'll say like bitmap.out PNG when you click on that. Basically, you can only have that code in there if you are making an image or a graph or a pie chart or something like that. Otherwise, you cannot have that piece of code in there. But anyway, we're just going to go ahead and start it. So today's agenda, basically just going to go from background to the basics of R Studio. Then we're going to do graphics and modeling in R. And then we're going to go straight into the demo. So what is R? R is both a language and a software. Interestingly enough, it's considered both. And it's a dialect of the S language, which was created by AT&T Bell Laboratories. Fun fact. And nobody ever hears of S, but everybody hears of R. So that's just something I always think is kind of interesting. R is a system for statistical analysis and graphics, and it is freely distributed under the GNU, General Public License, which basically means people can use it however they want to. And why use R? The first thing is it's pretty easy to use, especially not for non-programmers, because it's a very high-level language. So it's pretty close to, English, I guess, right? So it's high level, easier to use, further away from ones and zeros. And oftentimes the hardest part of R is actually just understanding the statistics behind all the functions and stuff that you're using. So Jonathan, you'll probably be having a field day here with all these statistics. And the language was actually designed by statisticians and data scientists. So it kind of lends itself well to these activities, and it's really a niche language for statistical analysis and data visualization. Unlike Python's like a multi-use, you can kind of do it for everything language, but R is very focused on data analytics and visualization and stuff along those lines. And it's used in many fields. I personally know people in non-STEM fields and even somebody in medical school who use R for labs and classes. So people all over the place use it. So I think that's kind of interesting too. And now we're going to get into the basics of R. So this code here is basically how you're going to have every single line of code be in R when you're doing a function. So it starts with the function, right? Function on the left side. The function is basically the actions you're performing on the inputs to get the output, right? So, and the arguments are essentially the input in that situation. So the arguments are the input to the function that create the output. So for instance, here in this mean function, mean is a function name. So you're taking the mean of the arguments, and the arguments here is this vector of these 5 numbers. So you're taking the mean of 1, 2, 4, 6, 7, and the mean would be 4, I believe. So the output would be 4, right? So function is basically actions, argument is the inputs, and then the output you will see. So now we're gonna get into the basic data types here. R is a little different than a lot of other programming language as far as data types go. So we have something called numeric, which is basically any number, and it could be a decimal, could be negative. So here we got 1.5, 55, and negative 6211. Yeah, so these are all just numerics, but we also have an integer type, which is basically just a whole number with no decimals, and it's indicated by this little L after it. So if you type 1L, that's going to be an integer, or 78L, that's going to be an integer. That's honestly not used pretty widely. It's pretty, I've never used it personally. So you don't really have to worry too much about this. Complex is, I'm sure you know from like algebra 2, any number that has an I in it is like an imaginary number. Once again, I feel like that's sort of a, if you're doing that certain stat activity, it kind of lends itself well to it. But for our case, in many cases, it's not going to actually help us. But it's interesting to know that they can actually store a complex number like that. A character is basically a string, if you guys know in other languages. So it's basically a sequence of characters of 0 to however many characters. And over here, we got some nice examples like kin and guan, p, and you can even put an integer, or excuse me, a numeric value into a quotations to make it a character. And logical is just, you know, your pretty standard Boolean, which is basically, yes, Ken, that is your name, which is basically a true or false value. But interestingly enough, you can also just use T or F. So there are the basic data types. Casting, which is basically making a certain data type another data type, right? So let's see here. Let's say we have the number 1 or 2 in strings. If we write as numeric and then that 1 in string, it will turn into a type numeric, right? The reason why I'm putting this slide in here is because in R, the functions a lot of times depend on what, like you'll get a lot of errors just because your types are wrong. So this is really important in R, I think more than other languages, because I've ran into so many errors. It's like, oh, there's type is wrong. I'm like, why is the type wrong? And it's just a pain in the butt. But so this is kind of how you do it, right? So you can change a false and a true to 0 and 1 respectively. An A, or like pretty much any other character or string of characters, will be an A. Logical, 0 is false. Any other number is going to be true. And then yeah, the strings F and T are going to translate to true and false. And characters will pretty much just turn any input you have into a character. Cool. Any questions? If you have questions, just put it in the chat or stop me. Oops, I think I went too ahead. Cool. So this next one here, we have basic data structures. We're not going to go too far into these. I'm cutting some of these out as far as like what I'm going to talk about, but I do want to mention 3 important ones. So the first being the vector. So as we can actually, let's go up here. So this is a vector right here, right? It's basically a sequence of any basically item, a sequence of items that are all the same type. This is used a lot in R. So yeah, I think that's just an important thing to cover. If you see this here, C, the C function is how you call and create a vector. So if you do C, red, blue, gray, that'll basically give you a vector of red, blue, and gray. If you add a 5 to it, or a numeric value, it will turn into a character or a string, which is interesting to note. Next important one is factor. So factors is basically used to create categories of data. A factor has these things called levels, and levels are essentially the original input without any duplicates, and that's also ordered. So it's very useful for categorical data. So an instance of categorical data could be, in the case that we're using, we have engine arrangements or sizes or types or whatever. So I don't know if you guys know about cars, but there's like a V engine. There's also a standard engine. So something like that. Or let's say we're doing ice cream flavors. Categorical would be chocolate, vanilla, right? So something like that. Now, the data frame is the last thing I want to talk about. It's basically your standard table. If you guys have used SQL, it's kind of very similar to like a SQL table and how that's kind of organized and created. But this is what we're going to use in R to analyze data. So once we import the data, it will be into a data frame. Different columns can contain different types. So we can have one column that's all Booleans, true or false, or logicals, I should say, since this is R, and another one be numbers, right? So, but within those columns, they all have to be the same type, which is an important thing to note. And you can also assign names to rows and columns. Cool. The rest of these, you guys can look up on your own and sort of just check that out. but I'm not going to talk about it for the sake of this lecture. And operators. So these are pretty standard. If you guys know any sort of coding, I hope you guys have a little bit of background, but basically you can add numbers, subtract numbers, multiply stuff. But there are some interesting things that I want to note here is if you're like from, if you code in something like Java, the and using one and is identical to using two ands as far as a comparison operator. So the comparison and, so for instance, if I say X is true and Y is true, that'll return true. But basically one and two ands are the same. And there's also this exclusive or operator here. So what this exclusive or operator does, it means one or the other. So if X and Y are true, it will return false. If X is true but Y is false, it will return true. If they're both false, it will return false. So I thought that was pretty interesting and it's actually pretty useful. So yeah, but other than that, this is just pretty standard. Now we're going to go into graphics in R. So this is the fun part of R. As we can see here first, I'm kind of going to blow through these real quick because we're going to actually make these in the demo. So here first we have just a normal scatter plot. It's using the plot function, right? So if you guys remember from the slide, one of the first slides I showed you, there's the function and there's the arguments. So the function here is plot and the arguments are X, Y, main, Y lab, X lab. I'm just gonna go through these real quick. X is basically the X axis, Y is the Y axis, so the data that's on there. Main is the title. X lab and Y lab are the labels of the X's and Y axes. COL is color, PCH is the shape of the dots, and the subtitle, sub is for the subtitle. So now we have the pie chart. It's pretty much the same. Just another cool visual I wanted to show you guys. And yeah, what is this called? Histogram? No, not a histogram, bar chart. So yeah, it's very similar, right? So you just sort of, it's cool. You can make these graphics with this one line of code, right? So this code up here is pretty much just setting it up, but the actual making the pie chart is, look at that. It's literally, this is one line of code. I just sort of made it look nice, but this is one line of code to make all of this. That's crazy, right? That's how powerful R is. Same thing here. It's one line of code, and you make that. Nuts. I think it's cool. I think it's super powerful. But yeah, so now linear regression. Does anybody here, can I get like a thumbs up, thumbs down for knowledge about linear regression? If you don't know anything about it, that's cool. Okay, so we got some thumbs ups. So basically I'm gonna show you guys how to do linear regression in R. Oh, we got a lot of thumbs up. Wow, good job. You guys paying attention in class. I love it. But so linear regression is basically, oh, what was that? Okay, I'll keep going. But linear regression is basically using data to predict other data. So for instance, or to get more specific, it's using X variables or independent variables to predict a dependent variable, right? So for the instance that we're going to use, we use the weight of the car to predict the miles per gallon that car is going to get. Yeah, so it's basically a prediction model. So you use other, I guess, data or information you have about something to predict another characteristic about it. So for instance, if you really wanted to, you could do factors for stock prices, right? So you can do like, put in information about like amount of traffic it gets on the internet. I don't know what else would work. If there's like a call, I'm not a finance guy. You know how they have their earnings call? That's what it is, earnings call, right? So you can use that stuff to predict what the price is going to be. That's the linear regression. Just a heads up, is not a good idea to use this. There's better prediction models out there for that, but that was just an example. But basically, to create a linear regression, you want to split the data into testing, into training, create a model with the training data, assess the model, basically look at the different things like the significance, which is you can see here with these 3 stars. I'll go into that later, and R squared. And then you want to validate the model with the testing set. And cool, demo time. I'm ready. How we all feeling about that part? I'm gonna set up the demo really quick. We excited for R? We excited to get some coding in? Okay, we got some excitement in chat. Love to see it. So Let me just, cool. Just give me 1 second. Sorry, I just got messed up. I'll be there in a second, but. Okay, cool. So does everybody here, I know you got a lot of you guys have RStudio installed. If not, you can use the link that I put in here before. I'll put it in again, so you guys can kind of follow along with the stuff. So can you guys see my screen right now? Can we get a thumbs up, something like that? Cool. All right, so I'm gonna basically just explain how RStudio is set up really quick. So this is the console down here. Sorry, I pointed the wrong place. Look at me go. The console is down here. As you see before, I put in the word boogers. I don't know why I chose boogers, but you can type whatever you want in here. So I can go Canon, right? It's gonna, oops, let me do this. I have to put it in quotes. Canon, and I'll print Canon. Oh, I spelled his name wrong, so I apologize. But so yeah, so you can basically print whatever you want here and do operations. So 1 + 1, it'll give you 2, it'll return 2. Crazy, right? And this is also where all the output is. So this notebook up here in the top left section, you can type whatever you want and basically have a list of commands that's ongoing. And if I type in 1 + 1, 1 + 12 here, it'll print out 13 in the console. Cool. I think it's pretty cool, at least. Over here, we have the environment. This will basically just show us all the data that we have. And over here is the help part, and also it shows you some plots. So I think that's cool once again. So let me just see. Let me go to variable storing. So if you guys know basic variable storing in like Python or something, you do x = 3. And that will basically say that when you call the object x, it's 3, right? It'll return a 3. So in R, it's good practice to do this. So you make a little arrow instead, right? So x points to 5. So the 5 is pointing to the x, and then if we print the x again down here, you'll see that this is 5. Let me move this part over here because it's probably annoying. So yeah, so there's a little interesting thing about storing variables in R. So you should probably use that arrow. But you can use the equal too, that's fine. So now we're gonna create a vector. I hope you guys remember what a vector is. So a vector is basically a sequence of items that are all the same type. So let's say y. In y, we are going to store the vector 1, 2, 3, 4, 5. And if we print y to the console, we see it says 1, 2, 3, 4, 5. How cool, right? So, all right, this is kind of the boring part. That's okay. I just want to show you the fundamentals. So if you want to get the mean of something, right, we can literally just type in the mean of y, right? So if we want the mean of this list, which is, you might be like, okay, well, I can kind of calculate that by hand. But if you have like a really long list, that's kind of annoying, I think. Let me just check the chat. Can you do y equals? Okay, Chris, you can use the equal sign, right? So let me just show you this. Let me just do this real quick. Y = 0, so I can reset it. So if we set this, y equals the vector, it'll come back to being that vector. So you can use both. But it's just good practice to use the pointer. Honestly, I'm not really sure why, but every single time I see R, that's what they do. So it's probably just because a lot of times in arguments you will have the equal sign, so it will probably get very confusing. So that's my guess on why they use it, but I'm not 100% sure. But anyway, back to here. If you have a really long vector, you don't want to calculate that by hand, so you just use the mean function. Super cool. Let me see what else we got here. Okay. I'm basically going to create a data frame real quick. So if you guys remember, the data frame is pretty much a table, right? So a table that you know in other forms, basically other, I guess, coding languages. So creating the data frame. Okay. We're going to make the columns first, right? So I'm actually just, in the sake of time, I'm just going to print these out already. So what this code here does, this 11 to 15, it basically creates a sequence from 11, 12, 13, 14, 15, right? So that's kind of what that colon there is shorthand notation of creating a vector and typing in 11, 12, 13, 14, 15. But all you need to know is that's numeric, right? So this column here, A is numeric. B is a vector of characters with the words AO, Kennen, Guan, Bala, Swag. And C is a vector of true or false variables, right? So to create a data frame, we can just, I'm gonna call this data frame DF, short for data frame. We can do data dot frame and enter A, B, C. So now we have our beautiful first data frame right here. Wonderful. It's called data frame. So it has, in this column, it has integer or numeric values, excuse me. Column B, it's all strings, and C, it is true or false. So logical values. Let's see. You can also name the columns, right? So these are right now are A, B, and C. That's because those variables were A, B, and C. So if we do names, DF, remember names is the function, data frame is the argument for the function. We can store in those values there a list of column names. So let's do call, oops, I gotta do my parentheses, call 1, call 2, and call 3. So now if we load back this data frame, we see, wow, it's called column 1, column 2, and column 3. Cool. You can also customize the row names, but let's just skip that for now for the sake of time. Okay, does anybody here code in languages like Python or anything like that, or has ever done that? Can I get a thumbs up if we have? Cool. So as you guys know, if you're indexing a list in Python, you start at 0. In R, you start at 1. Ew, right? I think that's gross, but that's just how it is. So I guess it's easier for statistical people since this is designed by statistical people. I'm not going to argue it, but yeah. So if we want to find a certain point of this data frame, we have to use this notation here. So it's going to be df square brackets, and let's say we want to find the point 3, 2. So that's the third row down and column number 2. So looking at this, that should be 1, 2, 3. That should be Guan. So, right? Wow, cool. So that's how we find a specific column or a specific point. So if we want to find a column, we can just do this. Right? So let's say I want column 2. Boom. I can just do data frame, have no number for the rows, and just type in the column number. Or this is what's usually done. I can do data frame $, column 2, and it'll print the whole row. So that's what's going to be used often, this $sign notation. But the same thing is how you do the rows, right? So if I want to get the row, excuse me, let's say I want to get row 2, I just do data frame 2. And oops, sorry, I have to do the comma. 2 comma, and it'll give me the second row. If I want to get multiple rows, I can do this function called, or this basically this shorthand notation for getting a list of rows. So let's say I want rows 2 to 4, so 2, 3, and 4. I can do 2:4, and I'll print out rows 2, 3, and 4. Wow, cool, right, guys? I know. So now we're gonna get into the fun part. So that was basically just kind of teaching you how to maneuver with the data. So now we're gonna go to the fun part. So our student, I guess R in general, has this data set in it called empty cars, right? So we are going to load this into a variable called data, but it's empty cars, not empty, but like the letter M, the letter T. So this is the data we're going to be using. So I recommend, if you guys are following along, to load that into the word data. And it's general practice, once you load in a set of data and you're going to use it, you want to kind of figure out like what is this data? Like, what do all these columns mean? What are all these, what am I looking at, right? So a good way to start is to do head data. So the head function basically shows you the first 6 rows. There's other arguments in head that can change the number of rows that you see and the number of columns that you see. So as we can see here, we have car names on the left side, right? This here we have MPG, SIL, DISP, HP, DRAT. So we have all these column names. I'm like, I don't know what that means, right? So we can do this fun thing. This is pretty much usually if you download data from the web or like whatever website you're doing it from, they will have documentation on what each of those columns mean. But we're lucky since we are using a built-in R data set, we can literally just do the question mark and MT cars, and all this comes up on the right side here. So we see MPG is miles per gallon. SIL is the number of cylinders. We have all this stuff here. Two important ones to note are the VS. So VS is the engine shape. So it's V-shaped or straight. And AM is transmission, so automatic or manual. So why is this important? Because it's a categorical variable, right? So when you're working with a categorical variable, it's treated differently than numeric variables. So essentially, the important part to know is you want it to be a different type of data because it is it's categorical, not numeric. And if it's not, your data is going to get messed up. So that's pretty much the reason why we have to note that. But let's see, we can do this function here called structure data. And so what this shows us is it shows us the column names along with the type here, right? N or num for numeric, and all the values here for each of the rows, of course, to a certain point. So as we notice here, so what is this? VS and AM, they're both not numeric, categorical variables, right? But the type here is numeric. We don't want that. So if you guys remember factor, I showed you guys factor, what a factor was. If we want to go back here real quick, let me actually just do that. A factor is basically a way to categorize data, as I told you before, and it'll show you, it'll basically get rid of all the duplicates in the data and let you see it as like different factors, different categories pretty much, right? So that's what we're going to have to do for this data. So we're going to have to make this data from numeric to a factor. So if to do that, basically we can just, let me pull this up real quick. We can change the data kind of directly. So if we do data and then excuse me. So data VS, which is for the, what is that for? The engine shape, right? So we're basically saying, okay, this right here, this column, data VS, we are putting into it factor data VS. So basically what we're doing is we're putting the same data that's in that column into it again, but as a factor this time, right? So if we do that and check it here, oh, we see right here, it says factor with two levels, 0 and 1. So this is exactly what we want. So basically just shows us, okay, there's only two like available options for this column, 0 and 1, right? So that's super important because there's only two ways that an engine could be shaped, at least in this data set, which is a V shape and straight. So that's all good. Basically, we're doing all this just to prevent errors later on. Let's see. We're gonna do the same thing for AM, which is the automatic or manual transmission. And if we go back and run this command again, we can see that it's now a factor. Cool. So now that we've sort of edited our data and we got a good look of what these columns mean, we can actually, let's do this first. So there's a function that you can run to even learn more about the data, which is summary data, right? So summary is the function, data is the parameter. So we're running a summary on the data. Oh, wow, look at all this, right? So we see for each column, we have our own values. So for here, it's basically a 5-number summary with the mean too. So all of the quartiles, yeah, so minimum, maximum, and first, third quartile, as well as a medium. And it gives us a bunch of information. And for the categorical variables, it shows us the occurrences. So 0 is a V-shaped engine. So there are 18 V-shaped engines in this data set. And there are 14 straight engines. And for the transmissions, there are 19 automatic and 13 manual. So that's, so that gives us basically an insight into the data that we're using. So now let's go to the fun part. We're going to graph the data. So remember how I said doing visuals and stuff is super easy in R? We can literally just go histogram, right? HIST is the function for histogram, hist data. And let's do a histogram for the, I don't know, what do we want to do, MPG? Right, so histogram for the MPG. Wow, look at that. We got a whole graphic there, right away. We literally, one line of code. We got a whole histogram here. I think that's pretty cool. So if we want to get fancy here, we can label it and name it. I'm just going to copy the code for basically the sake of time. So this main argument here, that changes the title here. So you'll see that the title here will change to distribution of MPG. The X label will change to miles per gallon, and the color will change to like a nice blue color. So boom, now we have our fancier histogram, right? Now I'm going to run through a few other types of plots. So if we want to do a plot basically to see the relationship between two variables in this one, I'm choosing to do the weight in the MPG, right? So when you're, okay, let's say right now we're trying to, because we will do this eventually, but trying to do like a linear regression model. You kind of want to see if there's a relationship between the variables before you use one variable to predict another variable. So a good way to do that is to visualize it with a scatter plot. So right here, we're going to see, oh, interesting. So as the weight decreases, the MPG increases, right? So we kind of get to see that relationship between these two data points. And if we want to make this look nice, once again, I'm just going to copy this code for the sake of time. But we have the X here is one argument, which is what's on the X-axis. The Y is what's on the Y-axis. Main, again, is the title. So cars versus MPG, or car weight versus car MPG is up there. Y lab is the Y label for weight. Yeah, so we already went through this in the slides. I'm not gonna go through it again, but you can just play around with a bunch of parameters. You can look up what the function is and what those parameters mean. And that's definitely the best way to kind of learn about any sort of function. So now, okay, let's go back to the data and just take a little gander at it. So if we do head data, okay, so we see there, let's go to the cylinder table, right? The cylinder column, right? So we can see there's 6, 4, and 8 cylinders. So what if I want to find how many of each there are, right? Because I don't know, that's kind of interesting, right? So how many 4 cylinders, how many 6 cylinders, how many 8 cylinders? Funny enough, we can actually use this command called table. So we can do table data cylinders, right? So I'm going to store this into the variable. Oops. 1 second. Let's do cylinder count. We're going to call it this, right? So now let's type out cylinder count. So, okay, cool. As we can see here from this little table it gave us, there are 11 4-cylinder engines, 7 6-cylinder engines, and 14 8-cylinder engines. Cool, right? Interesting to learn more. We're learning more about our data so we can kind of make assumptions and predictions about it. So let's do this real quick. This is all cool, right? So I can see the numbers, but a lot of times in business senses and even just like kind of showing people stuff, visualizations are much better than just showing them numbers, right? Because you kind of get to see and understand, I guess, the proportions and the comparisons between them. Like humans are just better at doing that than looking at the numbers and seeing it. So let's make a little pie chart. So I actually already pretty much I did the code for this. Once again, I'm just going to copy it in so we don't waste too much time. Let me explain what each of these are. So this my label is a variable that stores what the labels are going to be for the pie chart. This my color here is the colors I chose to use. Right, so if we run these commands, these will now be stored in the variables. And now for the pie chart function, let me just do it real quick. What a cool pie chart, right? I think it's cool. We have pretty much the rest of the information here. So once again, the labels here, this function is for my label, right? So 4-cylinder, 6-cylinder, 8-cylinder, 4-cylinder, 6-cylinder, 8-cylinder. The number of cylinders is in the main, right? So that's the title of it. For the colors, I used the variable I made, my color, and the radius one basically just made it larger. So if we get rid of the radius one here, let me just actually show you. If we run this, it'll just get smaller. So the radius one kind of made it bigger. And this init angle part basically changed where, let me just get rid of it and show you what it does. Oops, let me fix that. Yeah, so it basically changes the way that it looks, right? The orientation or the rotation of the pie chart. So cool. I'm sure you guys all know kind of what a pie chart is, what it shows you. So I'm not gonna get too far into that. But another piece of code here that we can do that I think looks nice too is another way to display this, which is just the bar plot, right? So, okay, this is kind of a little boring, right? So let's jazz it up with all those commands that we've been doing, all those arguments. So we get the same colors here, the same labels. We labeled the whole plot. We labeled the y-axis, but we also did the colors here, which is cool, right? But now something even cooler. Boom, we got a legend on it, right? So this legend function will basically add a legend to whatever graph output visualization you have. And this argument's top basically shows the location. So I can go top right here and I'll move to the top right. I guess it'll add another one to the top right and I can move it, right? So yeah, that's basically what that does. And then my label is basically just the list of things I want, and the fill are the colors that I want to have associated with it. Cool. Does that all make sense? Is everybody doing okay? Can I get thumbs up, snooze emojis or something if you guys are getting put to sleep? All right, we got some thumbs up. Love to see it. So let's see. Cool. So I'm gonna just do this real quick. I'm gonna plot the number of cylinders compared to the MPG. So looking at this graph, right? Because right now what we're trying to do is basically laying down the foundation to be able to predict MPG for a car. I'm trying to see, okay, do the number of cylinders have an effect on the MPG of the car? And as we can see here, although this graph isn't great, it kind of does, right? So the 4-cylinder cars seem to have higher MPGs. And as you get to 6 cylinders, you know, it seems like in the middle, and 8 cylinders is pretty low. So, you know, maybe there is some sort of correlation between the two, right? You know, it's not 100% certain, but looking at this, I'd be like, okay, you know, we're on to something here. So let's do this. Let me just, all right, let's do this first. I'm gonna make a nice little box plot. Let's see. Uh-oh, what happened there? Oh, I don't think I have the, okay, cool. That's it. All right. Oh boy. So what we're doing here is basically visualizing the data in a better way. Because remember, people understand visuals better than numbers most of the time, right? So, okay, so we can, I'm pretty sure everybody here knows what a box plot is. It's basically just a way to display information where this line in the middle here is the median. The color portion is basically the middle 50% of data points. And this top and bottom part is the min and the max, right? Yeah, so as we can see, the median for the 4 cylinders is definitely different than that of the 6 cylinders. And it's definitely different than that than the 8 cylinders, right? So it's just like interesting to see how these cylinder values sort of connect to the MPG and like see, okay, over here we can see that it's not very tightly distributed as 6 is or 8 is. So you can just kind of derive sort of, I don't know what the word is, but we can kind of figure out and make assumptions about the data by looking at these visuals, and it's super powerful. And if you're ever like presenting to somebody, presenting to, I don't know, like a boss, if you're in work, or like a CEO or something, like the visuals are what's going to actually move them and be powerful. The visuals and the big stats, right? So the visuals are super important. So that's why R is a great language, right? And now we can also do this if you want to see the summary of the data for basically based on the cylinders. So let me explain this real quick. This aggregate cycle basically will create an aggregation. That's for lack of a better word. It will basically, what this first argument here means is it will judge or I guess analyze the MPG based on the number of cylinders. So it will group the number of cylinders for each one and basically analyze the MPG from there. And summary is basically what function we're going to have it run. You can do stuff like count or put other things here, and data is the data that we're running. So if we do that and we display this, we once again get to see the minimum, the max, the quartiles, the mean, and the median. So this is basically this in a number form. It's basically this box plot in a number form. Cool. So now, since we're done with all this visualization and everything, we're finally going to get into linear regression. So we spent all this time kind of looking at what kind of just like looking at the data, seeing what we can do with it. So as I told you before, the best way to kind of start linear regression is to sort of look at the data and see what you're working with. But let me pull up the PowerPoint again, just for reference. So if we go here, the steps to creating a linear regression model, split the data into testing and training. I don't know if we have time to do that. It doesn't take too long, but basically to have part of your data to train the model with or create the model with, and then part of it to use to make sure that model is good, right? So you create the model with the training, and then you just kind of look at the model, look at the information from the model. It's like, okay, is this a good model? Is this a bad model? And then you validate it based on the testing data. So you put the data points that you left out before originally and put it into the model and basically say, okay, does this model work? Like, is this predicting accurately? Cool. So let's get into it really quick. But the best way to figure out like, okay, what do I want to use for my linear regression is to run a bunch of scatter plots. So luckily we have this function in R called pairs, and what it will do is basically run scatter. It's going to be very, pairs, excuse me. It will run scatter plots for every single variable against itself. If you guys see this, I mean, this is really small. I'm sure it's small on your screens too. Yeah, so this like all this information here is super helpful. We can kind of, you know, lean in, see it a little bit, but let's actually just shorten it for the ease of like kind of looking at it. So I'm going to take, actually, let me just do this, pairs. So we want to use only, let's say 5 columns. Let's say we're going to use the first 5 columns to look at. So basically, let me explain this a little more actually. So if we look here, like, let's say this, for instance, this scatter plot here is, we go over here, we see, okay, that's MPG and weight. So it's a scatter plot between MPG and weight. So if we want to, let's just do the first 5 so it's easier to read. We can do data, comma, 1 to 5. Oops, I did not do that right. So now we'll just have the scatter plots for the first 5 columns. So over here, it's MPG versus the number of cylinders, MPG versus the displacement, versus the horsepower, versus the drat. I don't really know what the drat is. Actually, let's do 6. So cool. And then finally the weight. So looking at these scatter plots, right? I'm trying to predict the MPG. So I'm looking at everything in this top row. To me, it looks like the most linear and the most one where I say, okay, that's probably a relationship here. It's either displacement, but it kind of looks exponential. So I'm going to ignore that one for now. But weight looks like a super, you know, looks like we're onto something. It's got a good negative decline slope, and it looks pretty linear. So maybe we can use the weight, right, to predict the MPG. So let's try that right now. So the first thing we're going to do here, actually, let me, for the sake of time, I'm going to skip splitting data into testing and training. But let's just make the model, right? So if we do M1 is what I'm going to call this model. The function to make a linear regression is LM. So if we do LM, the first argument is going to be MPG, and then it's going to be this little squiggly thing in the top left of your keyboard, and weight, WT, and then we can just write data is equal to data. So let me explain this a little bit. So let me run this. This MPG here, this is what we were predicting. So this is our independent variable, or this is our dependent variable, excuse me. So this is our y variable, and this weight here is our x variable, right? So we're using this x variable, we're using the weight to predict the MPG. So if there's actually this other command, which is honestly more useful. So actually, let's just do this first so I can show you. So M1, right? So this is what we get when we call M1. We just see the intercepts. Basically, what this says is if you increase the weight by 1, the MPG will drop -5. Okay, so it does show there's a relationship there, but it doesn't really show us like that good statistical stuff that we love, right? That actually the statistical significance that we need to show that this model works. So we can do this function called summary, right? So first of all, I'm going to do S1. If we do summary M1, it'll give us more data about the model that we just learned, or the model that we just basically created, right? So, oh, look over here. Dang, lots of information here. So let's kind of break this down a little bit. So the first part is just calling the formula. So this is what the formula is. That's what M1 is, the code that we input to make M1, right? The residuals is basically information about the residuals. If you know about statistics, like more in depth, that basically is how you prove like normal. That's like the part of the line assumptions. I don't expect you guys to know that. We're not going to go over that, but basically it's useful information. That's all I'm going to say. And over here, this is really the meat of it that we're looking at, the coefficients, right? So this estimated, or this estimate here, this 37 and this -5, this here is the estimate for the intercept. If you know linear regression, it's basically just kind of what you put in there. It doesn't really have too much significance, but what does kind of have significance is this -5. So if we increase the weight by 1, the MPG 1 as in 1,000 pounds, we will drop the MPG by about -5. So you'll get about 5 less miles per gallon by increasing the weight by 1,000 pounds. That's interesting, right? This next standard error, don't really worry too much about that. The most important part here is these last two parts. So this 1.9 times 10 to the -10th and 3 stars, mainly just the 3 stars. If you guys know stats, this PT value is basically your, what is it, a P value? I think it's P value. So usually you have to say, I hope you guys remember this, but from stats, to prove something is statistically significant, you basically set some sort of threshold. So usually that's 0.5, and you say, okay, if I get the statistic value below 0.5, I can say that this model is statistically significant with 95% certainty, right? So in this case, this 3 stars means that it is, the p-value is less than 0.001, which basically means this model is very significant. So with like almost pretty much 100% certainty, there is some relationship, statistical relationship between the weight of the car and the MPG. So that's a little dense, but if you know statistics, I hope you're following. If not, feel free to ask a question in the chat, or give me a nice hand raise. And if I don't call on you, you can just talk out too. That's totally cool. But yeah, so, and then let's go over here. The next most important part here is this multiple R squared. So if you know what R squared is, good. I'll do a quick explanation of it. Basically, the higher R, the closer R squared is to 1, the better. So 0.75 is pretty okay, right? Not super good, but it's pretty okay. It shows essentially, let me think about this. The value of 0.75 basically means that 0.75, or I guess 75% of the variation in Y is caused by a change in X. So in other words, 75% of the change in MPG is caused by this change in weight, or can be accounted for to it. So that just basically kind of a measure of model fitness. The higher, the better. So that's how you interpret linear regression. Let me see here. You're getting a little short on time. So we can also do multiple linear regression, right? So that was simple linear regression. So if we do multiple linear regression, we can do, I'm gonna call this model M2. We can just literally add here. Let's do horsepower, right? So is MPG, right? So linear model right? That's what that first one. This first argument here means we are analyzing, we're, I guess, predicting the MPG based off of the weight and the horsepower using our data, which is called data. So if we do M2 here, we run it. We call this M2. Actually, we don't need that. M2. We're going to basically make a summary of M2 and show what that is. So let's see. Okay, cool. So just kind of to reiterate, we'll go over here. These 3 stars here in the second row and the third row basically means, yes, this model is significant. These variables do have a significant impact on the Y value, which is the MPG. So in other words, the weight does contribute to the horsepower, or not the horsepower, to the MPG, and the horsepower contributes to the MPG. The R squared, well, it's a lot better, right? So it's 0.82, which basically means that 0.82% of the variation in MPG can be accounted for by these 2 variables here, right? Awesome. So we're kind of getting this model. So, okay, we could say, okay, given a certain car with a given weight and a given horsepower, we can predict the MPG, which is super cool, right? So now, but if you, as you guys know, and you can see here, there's so many variables. So how do we know which variables to use, right? Because I don't know, there's like what, 11 rows in this data set. Which ones are important? Which ones are not important? Luckily enough, we have this library called leaps. So if you guys are following along, you guys are going to have to run this command, install.packages, and type in leaps. So you guys are going to have to run that command, but since I already have the leaps package installed, I can just go library leaps. And so basically what this is loading library, which loads more functions. Cool. So the particular function we're going to use is called reg subsets. So reg, reg subsets. And we are going to basically predict the MPG, right? Use this little squiggly and put a period here. What this period means is basically every single variable besides MPG in the data set. So if I wanted to, I can go through, I can go weight plus horsepower plus whatever, but that gets kind of annoying. So if you just put the period in there, it does every single column, which is super useful, right? So data is equal to data, right? Because that's the data set that we are using. And let's see, the method is equal to forward. What this basically means is, what this reg subsets function does is basically finds us the best model. And there's a few different methods, like there's backwards too, but we're just going to use forward for this example. That the details are not super important. If you want to learn more about it, I definitely suggest looking up because I think it's pretty interesting. But so now we're going to go summary M3, and we're going to display this summary. So okay, you might be like, what the heck is this? This is not what we saw before. But what this does is it shows us basically what is the best model based on R squared, like which variables do we need in the model to have the highest R squared, or adjusted R squared, I guess, right? This form is not the best to read. So if we go here, and for the sake of time, I'm just going to copy this in. Let's go here. We can actually create a plot to see exactly what this data means. So as you can see on the y-axis, it has adjusted R squared in ascending order. I guess it's, yeah, I guess that's what ascending. So as you go up, the R squared gets higher and higher. And on the x-axis, there are all the variables. When selecting a linear regression model, you want to balance, okay, I want a good R squared, but I also want to make sure that all these variables are significant. So you kind of use this as a basis to know, like, okay, using weight alone is kind of, it's, you know, not the best R squared, right? It's 74, but once you use 2, so if you use the cylinders and the weight, that's a pretty good R squared, right? 0.82, and it doesn't really get much better. It gets to 0.83. But honestly, at that point, it's pretty negligible. So if you go through all the graphs and go through all these functions here, the one that's really going to give you the best R squared is going to be the one that's literally just the number of cylinders and the weight. So let's do model 3A is equal to LM MPG. Let's do cylinders plus weights, and then data equals data. So if we go here, we go S3A is going to equal summary M3A. Cool. And then display S3A. So that kind of just gives us, the same linear regression output that we had to the model, similar to the models before, right? But we can see here, this R squared is better than the models that we used before. And these variables are significant. So that's great. It's a very simple model and it's pretty effective. So this reg subsets command is just very, very useful. That way you don't have to sort through all these models to figure out what the best model is, but it just orders them by R squared. So this is pretty much all we got for today. But if you guys, here, let me just show you one thing. This is kind of like very introductory level R Studio, but what we can do here actually is there's this library called RGL. This is just like I'm trying for fun, like not really important, doesn't really say much, but I can run this command here. I don't know if you guys can see this. Can you guys see this? You get a thumbs up? Cool. Look at this. Boom. What the heck? Right? You can go with 3D plots in R. Isn't that crazy? To be honest, I don't think it's super useful, but it's so cool, right? I think it's awesome. But so I want to show you guys that. But yeah, so that's pretty much all we got for today. If you guys have any questions about linear regression or anything else, because we didn't really get through everything I wanted to, feel free to stay back and ask some questions. But yeah, if not, you guys are free to go. Thank you so much for joining me today. I hope you guys come out to our next workshop, which is Tableau. And yeah, have a great rest of your Wednesday night.
Thank you, Alec. Beautiful.
You're welcome, Kenan. Thank you. Thank you.
Beautiful.
That cube at the end, the 3D plotting makes me miss my